In this video, I'm going to demonstrate some common lens changes that we make. This is an OrthoK lens, and the two things we're looking to do are to adjust the overall diameter of the lens and also loosen how the lens fits out in the periphery. So up at the top right corner, we have the diameter of the lens, and because the placements of the different zones within the lens are affected by how large the lens is overall, changing this may change the positions of these control points. So if we right click on the graph, we can see we're at 5.6 and 6.2 for the red and blue control points. And if we decrease the diameter to 11.0, we can see now we're at 5.3 and approximately 5.9. So if this is where you want the new control points to be, then we do need to adjust the power of the lens because that changed. By shrinking the zones, we are effectively getting more central push, and so we want to adjust that accordingly. If we want to maintain the previous 5, 6, and 6.2 dimensions, then all we do need to do is drag these back out. So I'll drag this to 6.2 again, and then the IC lift change in the top left corner we want to maintain at 0. And then we'll drag this out. 5.6 also maintaining 0. So if we restore the red and blue control points to their original positions, then we'll have the original amount of demand, central push. Power and base curve will be the same as before. In that case, we don't need to make any vertical adjustments because we have not changed the positions of these. We just compensated by what changed when we altered the overall diameter. The next thing we're going to do is loosen the periphery out here, and we can do that from two places. One is here at the blue control point, which will change everything peripheral to that, or we can change at the pink control point, which will change just the very periphery of the lens. So if we want to change the entire alignment curve, another way to think of loosening the lens is we are flattening the overall profile of the lens or lifting the lens away from the cornea. If we want to lift the entire area here, then we'll control from here, from the blue control point, and that'll lift everything peripheral. If we want to leave the relationship between the lens and the cornea approximately as it currently is over here, and just affect posteriorly, then we can make the change at the pink control point. Whether you're making the change from the blue or the pink, a good idea is to right click on the graph and just see what the sag values are currently. For example, right here in this meridian, we're at 594 microns at the blue control point and 1637 microns at the pink control point. What I'm going to do is decrease the sag value. We're going to, again, flatten the overall profile of the lens, lift it away from the cornea, and we'll use a hypothetical target of 10 microns. So once we're finished with the adjustment, we should read a sagittal depth of 584 microns at the blue control point and 1627. In this case, let's say I want to make the change all the way around the lens. So I'll leave our design in 100% mode, and we'll click up a couple times here. And then I'll right click again to see where we are. So we're at 587, maybe one more. Okay, 584, that's our target at the blue, and we wanted 1627 here, so we've lifted a little too much. Come back down. Pretty close. So we'll fine tune that, and we are at 584, 1626. So it kind of flips between 1626 and 1628. and sometimes the software will not allow you to get that exact midpoint. Either one should be fine. So we've effectively lifted the periphery of the lens away from the cornea. It will appear in the graph that the apex of the lens is settling onto the apex of the cornea more heavily, and relatively, that's the relationship we would expect to see.